3, guys, I have a spring. So I'm going to apply the work and energy principle for the elastic force, all right? But what I want you guys to do here is to read carefully this question, right? Because, in fact, you should differentiate between S1 inside the elastic work of the elastic spring, which is L1 minus L0, and S given in this figure. They are different, right? So let's read this question. I have a 0.5 kilograms ball of negligible side, and it's fired up the vertical smooth circular track using a spring plunger, all right? So how the spring plunger works, in fact, if I pull back the spring plunger, this here will be pulled also back, and the spring will be compressed. Now, when I release the spring plunger, then the spring should return to its original length, and then it will push this ball A all around the circular path. They are saying that the plunger keeps the spring compressed by 0.08 meters when S is equal to 0. Which means, guys, this is S. It's different than S1. They are saying that before pulling back the spring, before pulling back this plunger, I have a compressed spring by 0.08 meters. The question is to determine how far S. How far S? So what is S? How far S must be pulled back and released so that the ball will begin to leave the track when theta is equal to 135. So when I am at B, this ball should leave the track, all right? What is S? So that after releasing this ball should leave the track. Okay, guys? So this is the question. Let's start. Before doing anything, guys, I'm gonna find S1. What is S1? Is the length of the spring at the release, right? Whenever I release this plunger, what will be L1? First of all, guys, before pulling this plunger, the spring, when S is equal to 0, the spring, guys, was compressed by how much? By 0.08 meters, all right? Which means, guys, this spring has an L0 equal to this L prime here, which is before pulling back this plunger, plus what? Plus 0.08. Because the question, guys, is saying that this spring is compressed before pulling back this S. All right, guys? Which means, guys, that L prime is equal to L0 minus 0.08. Now, what if I pull back this plunger by an additional S? So, guys, now I'm pulling back this plunger by an additional S, which means what? Which means, guys, that this spring is now compressed by an additional S, all right? So this spring is now compressed by an additional S, all right? Because the spring will be compressed by the same value that I am pulling back this plunger with, right? So since I'm pulling back this plunger by S, then the spring will be further compressed by the same S, which means, guys, what's the difference between L1 and L prime? L1 is equal to, or L prime is equal to L1 plus this S. So L1 is equal to this L prime minus this S. All right, guys? So I'm gonna repeat. First of all, before pulling back this spring, I am compressing the spring by 0.08, which means L prime is equal to 0 minus 0.08, because at this stage the spring is also compressed by 0.08. Then I did an additional compression by S. All right, so I did an additional compression by S, which means, guys, that this L1 will be equal to L prime minus this additional compression, which is S. My objective is to find S1. What is S1? So why is my objective to find S1? Because in fact, I need to find the work, and the work is related to S1 and S2. Now, S1 is the current length minus L0. So if I substitute L1 by L prime minus S and L prime by L0 minus 0.08, then you're going to have L. So if you simplify by L0, what will be S1, guys? S is S. Who can tell me why S1 should be negative? Compression, perfect, Noor. All right, so guys, because this is a compression, so I am sure that S1 should be negative. All right, now, if I want to apply the principle of work and energy, what do you think? What are the states? Or between what states should I apply this principle? A, between A when S1 is equal to minus 0.08 minus S, and between state B when this ball is leaving the track. And this is the question. Determine how far S must be pulled back and released so that the ball will begin to leave the track when theta is equal to 135, which means when it reaches B. All right. So I need to apply the work of principle, the principle of work and energy between A and B. And guys, it's not between S is equal to 0 and S. This is not correct, because the question is to find when or at what S this B will leave the track, which means it is between A when this ball is released from rest and when S1 is equal to 0.08 minus S, and between B when this ball is leaving the track. So let's apply this. CA plus the sum of work between A and B is equal to CB. Now I know that at A, the ball is released from rest, which means TA is equal to 0. So let's, guys, substitute this work by the equations of elastic and the weight. Because in fact, guys, if you go back to this one, I only have two forces. The spring force at A, there is no spring force at B, because here there is no attached spring, and the weight between and the weight at A and the weight at B. All right, which means, guys, the only two forces governing the motion of A are the weight and the spring force. The normal force at A has a zero work because it's always perpendicular to the motion. All right. So I'm going to have only the work of the elastic force between A and B and the work of the weight between A and B, and this will be equal to GB. Now I know that the work of elastic force is half KS1 squared that I know in terms of S minus S2 squared that is equal to 0. Why? Okay, so I'm going to, yes. Why S2 squared is equal to 0? Because S2 is SB. And in fact, at B, there is no spring attached, all right? So no spring attached. So there is no elastic force. At B, guys, the spring is returning to its initial length, all right? Which means that I only have S1 plus the work of the weight. What is the best equation to be used here for the work of the weight, guys? In fact, it's minus mg delta y. Why? Because I can find this delta y. So what is delta y? It is yb minus ya. So it is positive. Now what is YB minus YA? It's this radius because this is a circular path, 1.5, plus this distance here, which is 1.5 cosine this angle, which is 180 minus 135, which is 45. All right? So the work of the weight is minus, so it's not plus, it's minus mg delta y, and delta y is what? Is YB minus YA, which is 1.5 plus 1.5 cosine 45. All right? So this is equal to half mVB squared. So let's now substitute the equations by their values. So now, guys, I know that half K S1, what is S1? S1 is S plus 0.08 squared. I remove the minus sign because it's a squared, plus, or minus, sorry, mg 1.5 plus 1.5 cosine 45 is equal to half mVB squared. Can I find now S? So the question is to find S. Can I find S now? Alright, so guys, I am saying if I substitute this equation by their value, so I know that S1 is S minus S plus minus 0.08, and I know delta Y. If I apply the work and energy principle, can I now solve for S? Can I now solve for S? Guys, can I now solve for S? We have to find VB. Perfect. All right, so I cannot solve for S because I don't know VB. I don't know VB. How can I find S if I don't know VB? So I cannot find S because I have two unknowns, VB and S. Can you guys find VB? Let's go back to the question. The question is to determine how far S must be pulled back and released so that the ball will begin to leave the track at V. How can I use this question, this sentence, the ball will begin to leave the track at V, in order to find VB? What does this mean? The ball is leaving the track means there will not be any normal force at B, all right? So B here, the ball at B will leave the track, which means there will not be any support, and this means that N at B will be equal to 0. All right, so what are the remaining forces? I only have the weight, because at B I don't have any elastic force. I only have the weight, all right? How can I find VB from this fact? In fact, guys, if you put the tangential force, sorry, direction, this is AN, in fact, and this is AT, and I know that this angle is 45, because they are vertically opposite, then guys, I can find VB by applying the equation of motion in normal direction. So by applying sum of Fn is equal to MAN, and I only have the weight, then this means, guys, that plus, in fact, the projection of the weight on N on the normal is plus cosine 45 is equal to M V squared over R, and R here is 1.5, sorry. Right, so the radius is 1.5. So now you can find V, and whenever you find VB, or you can find VB squared, in fact, because I only need VB squared here. Whenever you find VB squared, you can find S. Any question?